Hey class, Mrs. Anderson here. This video is going to go with your notes for 12.4b, and note that you will need a z-score table for these notes. So make sure that you have either printed, downloaded, have some sort of z-score table, got a copy from me before you take these notes. So this is day 2 of z-scores. So first, remember that a z-score, I'm just going to do a quick review of the z-score. The z-score tells us how far away something is from the average. So if we have a z-score of 1, we're 1 to the right of the average. Z equals 2, we're 2 to the right of the average on our normal curve. Z equals 3, we're 3 to the right. Z equals -1, we are 1 to the left. Z equals -2, 2 to the left. If Z equals -3, we're -3, we're 3 to the left. So Z tells us how far we are, how far from the average, how far, like in how many standard deviations we are from the average, and which direction. And so today we're going to look at z-scores where they don't fall, like what if you are 1.5 away from the average, what is the area under the curve? So that's what we're going to look at today. So here we have a cumulative area, and we're going to find that cumulative area for a standard deviation of 1.15. So this would be like you are 1.15 above the average. What's the probability that that happens, that you are 1.15 above the average? So that's when you take out the z-score table, which looks like this is a big table. So I've kind of zoomed it in. So 1.15, you look at the first column here and you find 1.1, and then you go over in the row and then find you find the row 1.1, and then you find the 0.05. So this gives you the ones and then the tens place, and then up here gives you the hundredths place in your decimal, so the second decimal. So 1.15 would be that circled one right there. So that tells me the z-score table always gives me the percent below that, or below, or we'd say to the left. And so 0.8749 is what decimal corresponds to a z-score of 0.15. So that means that there is 87.49% of the data below 1.15 standard deviations away from the average. So that's how we can use a z-score when we don't have an exact percent. Because before, if I said you're at 1 standard deviation away from the average, then we had these nice percents, 34, 34, 13.5, 2.5 out here. That's where we could add up all of these. But if you're 1.5 or 1.15 away, then we need this extra amount in between, and we didn't know what that was. So that's where we use the z-score table to find that. And then the z-score table has a negative side to it, so it's got a front and back. So if you're to the right of the average, you use the positive. If you're to the left, you're going to get a negative z-score. Then you flip it over. So if you want to find negative 0.24, you find the negative 0.2 in the row first, and then you find the 0.4 in the column, so negative 2.4, and then where those meet is 0.4052. So right here to the left is 40.52% of the data. So almost 50%, it's very close to the middle, but it's a little bit to the left, so it's a little bit under 50% of the data. Now if I wanted to know, so this is below that standard deviation. If I wanted to know how much of the data was on the other side or above it, then remember that this is gonna, that it adds up to 100%. So if you wanted to know how much was above it, you could take 1 minus 0.4052, or 100% minus 40.52%, and you would get 0.5948. So there's 40.52% below that standard deviation, and there's 59.48% above the standard deviation. So here's an example for you. So verbal SAT scores. What percent of test takers obtain a verbal score of 470 or less given that the mean of 500 and a standard deviation of 100? So you know that, there's 34% between this one, 34% here, 13.5% here, 2.35% and 0.15% out here. And then you know that there's 13.5 here, 2.5 or 2.35 and then 0.15 out here. And so if I said, what's the probability that a student scored between, 600 and 700, you could tell me easily that that's 13.5% that they scored between those two numbers. But if I said, what percent of test takers scored a 470 or less, then 470 falls right here between 400 and 500 because my standard deviation is of 100 and my average is 500. And so I don't know, how am I going to split this? I know that this whole bar from here to here is 34%, but how do I split it up and figure out what percent? So I'm looking for the orange right here. I'm looking for 470 or less. So then what I need to do is I'll need to find the z-score, because the z-score will give me how far it is away from the average to the left, and then I can use that number to find the z-score table will give me the percent of data. So first find the z-score, you take the number 470 minus the average and then divide it by the standard deviation of 100. So that's going to be negative 30 divided by 100. So negative 30 hundredths is negative 0.30. So 30 hundredths. So then I'm going to look at my z-score table. And I need to find negative 0.3, negative 0.30. So that's right here. Negative 3 and then 0. So we're at 0.3821. So 0.3821. So the z-score of 470 is negative 0.30. And the area to the left of the 470 then, so I'm using A, area to the left of 470 will be that decimal that I got, 38.21, which tells me that 38.21% of test takers score below the 470 or 470 or less, because the z-score table always gives me the percent to the left of that number. So that's how you use that z-score. So let's practice a few more here. Using the normal distribution with a mean of 25 and a standard deviation of 15, find the area under the normal curve. So I'm just going to do a quick sketch of what this might look like. So first I'll find the z-score, I guess. So z-score for 30 would be 30 minus the average mean of 25 divided by the standard deviation of 15 is going to give me 5/15 or 1/3. So you're going to have 0.33. So that means I'm 0.33 to the right of the average. So if you look at your normal curve, you have the average of 30. 0.3 to the right would be like right here. And then if I use my z-score table and look up the percent that goes with that z of 30, so the area of 30, it's going to give me the percent of data that's to the left of that then. So if I look at my z-score table for 0.33, 0.3 right here, and then go over to 3, it's going to be 0.6293. So 0.6293, or you could say 62.93% of data is below or to the left of that 30. Oh, I labeled the average was supposed to be 25. And then 30 was just a little to the right there, 0.33 away. So that's that one. So 45, if I found the z-score for 45, I would take 45 minus the average of 25 and then divide it by the standard deviation of 15. It's going to be 20 over 15 or 1 1/3. So you're going to get 1.33. So now looking at my my normal curve, the average was 25. and standard deviation of 15, so 25, then I'd be out at 40, would be my first standard deviation away. So 45 is going to be 1.3. So my next standard deviation's here, and my third one. So 45 is going to be right there. Now, if I find the z-score for 133, it's going to give me the area to the left or below 40. So how much data is there below 40? So 1.33. So go down to 1.3 and over to 3, and I got it highlighted there, 0.9082. So 90.82% of the data is below 45. And you can see in the picture that's represented there too. So for 10, the z-score for 10 would be 10 minus 25 divided by 15. So z-score for 10 is actually just -1. So 10 is exactly then one standard deviation to the left. So 25 minus 15 is 10. So the area to the left of 10, if you use what you've learned, this is the 34%. So this is that 13.5 plus 2.35 plus 0.15. All that adds up to 16%. So our z-score should kind of correspond to 16% is less than 10. So let's look up the z-score for -1. That'd be -1.0, which is right here. So over on my z-score table. And so you get the area to the left of 10 is 0.1587. So that is how much data, or approximately 15.87% is below 10, which is 16. So it's very close to what we did, but in our calculations with the normal curve, we're rounding to 2 decimals, and the z-table goes out to 4. So that's why it's 15.87, because we're rounding and they're keeping more decimals. So it's very, very close, but theirs is more exact technically in the z-table. So if you did z-score for 22, I'm just going to give you the answers if you want to try it. I got -0.2. So the area to the left of 22, I got 0.4207, or about 42.07% of the data is to the left. So if you want to give D a try on your own, that's the answers that you should get. Let's look down for a couple of these. So these ones are between 65 and 80 for the first one. So we have a normal distribution with a mean of 100 and a standard deviation of 20. And I want to find the area under the normal curve between 65 and 80. So I'm going to sketch the normal curve, and I'm going to show you what this is going to look like. So I have an average of 100 and a standard deviation of 20. So I'm going to have 120, 140, 160, and then I have a 80, 60, and 40. And I want between 65 and 80. So I really want between 65 and 80. So just this little piece. So it should be less than 13.5%. So just a little piece there. So how am I going to get that? Essentially what you're going to do is you're going to use your z-table. You're going to find how much data is below 80. And then you'll find how much data is below 65, but then you'll erase how much is between, or like how much is below 65, and that'll be left with what's in between. So essentially you're going to find both, and then you will subtract off one of them to get what's left in between. So to find the z-score for 80 first, you do 80 subtract 100 divided by the standard deviation of 20. So, and 80 is exactly one away to the left, so the z-score is -1. So remember that the value for a z-score of -1 was -1.0 is the -1.0 has a score of right here, 0.1587. So the area for under 80 to the left of 80 is 0.1587. So about 16% of the data is less than 80. Then for the z-score of 65, you do 65 minus the average of 100 divided by 20, and you would get -1.75. And so looking at -1.7 and then over to 5, trying to be careful here, I got 0.0401. So I got an area then below 65 is 0.0401. So then if I want to find the area that they share or the overlap between them, I'm going to take 0.1587 and subtract 0.0401, and I'm going to end up with the area that's between them. So 6811. So about 11.86% of the data is between those two numbers. So between those two numbers. Less than is the standard z-score table because it always gives you the area to the left. So whatever you get for the z-score for 45 is negative 2.75. So the area that you get when you do the z-score of that, you get 0.0030. So 45 is way to the left of the average there because the average is 100. So this is 0.3% of the data is less than 45. So that's the answer that you get. So now if you need greater than 115, first find your z-score for 115. So 115 minus 100 divided by the standard deviation of 20 is going to give you a z-score of 0.75. Then if you look at your area for 115, so look at your z-score for 0.75. Zoom in a little bit. 0.7, and then go over to 5. This would be right here, 0.7734. So 0.7734. Now you got to be careful because here is 100, here's 115. This 77% is to the left, so it's actually below 115. So if you want the standard deviate or the area percent above greater than you, then you have to take 1 minus 0.7734, and that will give you 0.2266. That's the percent that's greater. So that's your answer, 22.66%. You can give me either answer, but if you give me with the percent sign, then you do have to move the decimal to the left so that it's in a percent. Do one more between 100. So 100 is the average. So 100 and 135. So since 100 is the average, when I find the z-score for 100, you're going to get 0. And if you look at your table for 0, that's way down at the bottom here, 0.5, or way at the top on this top one. So the area to the left of 100 is 50% of the data. So the area for 100 is 0.5000. So that's to the left here. Now the z-score for 135 is you do 135 minus 100 divided by 20. You're going to get a z-score of, let's see what I get, 1.75. So if I look at 1.75 again, I think I had that one circled on here. No, 1.75 is 0.9599 right there. So 0.9599. So the area for 135 is 0.9599. So that is this area here to the left of 135. So if I want just where they are between, then I'm going to take the bigger area, all of the orange that I shaded there, and subtract the pink shading. So that's going to leave me with the yellow that's in between. So you have to take 0.9599, subtract off the 0.0 or 50%, and you're going to be left with 0.4599. So about 45.99% is between those two numbers then. Between those two numbers. Okay, I'm going to do one more example. I think I'm going to skip the cell phone one for now. It is filled out in my notes if you'd like to see that one done. And I think I'm going to do the manufacturing light bulbs one. So light bulbs with a life expectancy with an average of 500 and a standard deviation of 100. So if I look at my normal curve, I have an average of 500 and a standard deviation of 100. So it'd go up by 600, 700, 800, and then down 400, 300, 200. And I want what percent of light bulbs can be expected to last between 500 and 670 hours. So between 500 and 670 is what I'm looking for. So between here, how many, what can I expect to last there? So first, since the 500 is the average, the z-score for 500 ends up being 0. And then the area below, or the area to the left of 500, then the z-score that corresponds to 0 is the 0.5 because it's 50% to the left of the average. So the area to the left of 500 then is equal to 0.50. So that gives me this area here. 50% of the data is to the left of 500. Then for 670, how much data is to the left of 670? Take 670 minus 500 divided by the standard deviation of 100. You get 170 over 100, which is 1.70 then. So using my z-score table, 1.7 and then 0 would be the first column at 1.7. So 0.9554. So the area for 670 is 0.9554. So that gives me this area right here. So all of this to the left of 670. And if I want just this part right here, I'm going to take the bigger one, the whole green, and I'm going to subtract off the orange. So I'm going to take the 0.9554, subtract the 0.50, and you're going to end with what's left, or what I highlighted in yellow, or 45.54% of light bulbs are expected to last between 500 and 670 hours. So that's how we apply the z-score. So we have to first know how to use the z-score and then practice finding the table and then applying it. So we're going to do one more video or one more lesson on z-scores for tomorrow, and that's going to apply it more to applications. Thanks for watching.